Hi guys, and welcome to another video. Today we are continuing with our grade 12 paper 1 revision, and we are doing a hyperbola graph here, question 4.5. Let's get to it. If you are wanting to do this past paper from the beginning with us, then there is a link in the description to the paper, and there's a playlist which starts from question 1 as well, so you can do it along from the beginning to the end. If you are wanting just to get the answer to this question, let's begin. So we have a hyperbola here, f of x equals 4 over x minus 3 plus 4, and we have worked out the axis of symmetry with a positive gradient, which I put here in red, and they want the coordinates of A. Now we notice that the A is where the hyperbola meets the axis of symmetry, and so we can simply just make them equal to each other. So we can say 4 over x minus 3 plus 4 is equal to x minus 1, x plus 1. Okay, now what we can do, we can take our 4 across. Okay, so I'm going to make that x minus 4 when it goes to the other side, so we'll end up with 1 minus 4, which will be minus 3, and so we'll have 4 over x minus 3. Now we can times everything by x minus 3, and we get 4 equals, and then when we times this by x minus 3 here on the other side, we'll get x squared minus 6x plus 9. So when the 4 goes across, we get a 5, and so we'll have x squared minus 6x plus 9 plus 5, and so that'll be equal to 0. And then our solutions will be, and we're going to just do it on the side here, x, and it's negative, so it'll be negative 5, negative 1. And so x is equal to 5, or x is equal to 1. Okay, so we know that this one would have to be where x is 1, and so this one would be here, a would be where x is 5. Okay, and then we simply just sub in our 5 into either to get our y. Well, we know that then, I'll do this in pink, y equals 5 plus 1, which is 6, and so our other point is 6. So the coordinates of A are 5 and 6. Let's go on to the next one. 4.6 asks, it tells us, should I rather say, that, just clear all this, it tells us that there is a single transformation applied to obtain a new graph where our 4 becomes negative 4. And so what that means is, and we see that there's a plus 3, okay, and so plus 3 means our asymptote becomes minus 3, right? So here we have x equals minus 3. Okay, now what we notice here is that it's still plus 4, and so it's simply just now gone up by 4, so it stays as along there, and I'm just going to draw where it would then become. So now the new asymptote is this one in pink, and the horizontal asymptote remains at x equals 4 because of the 4 here. So let me just write that down. Sorry, y equals 4. I'm sorry for saying x equals 4. So we've got that asymptote there of y equals 4. The x equals negative 3 from here. And so we can then draw, it's now a negative, so it's in these quadrants, so it's over here. Okay, so what we notice is that this is a mirror image, and so this is now negative 5, but it's still 6. And so the length of AA is simply negative 5 to 5. So negative 5, so the length of AA is equal to 5 plus 5, which is equal to 10 units. Okay. Okay, so what we have here, because it's negative, is we have a reflection in the y-axis. Okay. Alright. Let's go on to the next one. I think that... Okay, so the next one now is a parabola graph. So we'll just do this one here, and then we will probably move on to another video. I'll do the rest of them in another video, so this video isn't too long. Remember, all of these will be put on a playlist in order, so that you can, whatever question you want, you can just simply click on that video. If you want to do the past paper with us, you simply just start at the beginning of the playlist, download the past paper, and then you can do it along with us. And when you get stuck, you simply just watch the videos. Okay, so they want us to show that we have a parabola of f of x equals negative x squared minus 4x plus 2. So what we need to do is we need to know the different forms of a parabola. Okay, so the first one is this form, right, which is our y equals ax squared plus bx plus c. The next one is y equals a over x. I'm going to put here minus p squared plus q, even though they put it as plus p, because what this means is this is the turning point formula where p and q are turning points. It's very important to remember that if it says minus 3, our turning point is 3. So let's say if it was minus 2 plus 4, the q would be 4 going there, but if it was minus 2, the turning point would be 2. And if it was plus 2, the p value here would be minus 2. Okay, so the x value of the turning point is the opposite sign of what's in this bracket. Okay, so that's where x... So this is the turning point formula. And the other one, which is not here, was the a equals x minus x1, ax minus x2. And this is where x1 and x2 are your x-intercepts, right? So depending on what they give you, you could simply just get the equation of the parabola. So here, they give us the turning point and another point. So we can sub in our values here. Okay, so we'll have f of x equals a. Okay, so f of x. So f of x, this basically means y, right? Let's do this in the color orange. Okay, so a y value here would be negative 4. So we could just simply sub in negative 4. What we're ultimately trying to do here, guys, is we want to solve for a, because that's what we're not given. Okay, now in x, we are given an x value here of negative 3. Okay, so let's do that in a different color. Negative 3, so that's there. That's our x. So that's negative 3. Now, the turning point. If you are given the turning point as minus 1, you need to change the sign of the x value to plus. Okay, and then that's squared. And then your q is your y value, and that's your 4 here. And so it'll be plus 4. Okay, and this is all in the name of solving a. Okay, so negative 3 plus 1 is negative 2 squared is 2 times 2, which is negative 2 times negative 2, which is 4. So we get negative, I'm going to drop the colors now, negative 4, take the plus 4 in green to the other side, and we get a, and then this is a 4 here. And so we get negative 8 equals a to the 4a, divide both sides by 4, and we get a is equal to negative 2. Okay, and now we can sub that in order to get into this form. Okay, so now we've got our negative 2. We can say y, let's say f of x. So f of x equals our a, which we now know is negative 2. Our x, and then our p, remember, is our plus 1. squared and then plus our 4. And so we get negative 2. And then when we times this out here, the x plus 1 squared, we'll get, let's just put a square bracket there. X squared plus 2x plus 1 plus 4. And so when we times this out, we get negative 2x squared minus 4x minus 4, minus 2, because negative 2 times 1 is negative 2, plus 4. And so, do we see here, we get exactly what we're supposed to, which is negative 2x squared minus 4x plus 2. And that is done and dusted. Okay, now let's go on to the next one. And we have, they want the values of k for which f of x plus k will have no real roots. Let me clear all this now. Okay, now whenever you see roots, you need to remember you have to get your delta, which is equal to b squared minus 4ac. So that's a little hint for this question. I will continue this in the next video. Thank you very much for watching. Please like, subscribe, all that good stuff. I take a lot of time putting this together onto slides so that the guys, especially looking on their mobile phone, are able to see this and it shows up nicely, because if I was just to show you the actual paper, it would be, this writing would be very small. So I take a lot of time on these videos. I hope that you appreciate it and you like it and all that good stuff, and I will see you in the next one where we will do question 5.2.